Part 1, use the substitution u is equals to tan x to show that this would be equals to 1 over n plus 1. All right, let's see. So if we're using the substitution, let's start with changing these limits. We're told that u is equals to tan x. So u is equals to tan 0, the lower limit. That will give us 0. And when u is equals to tan pi by 4, which is the upper limit, this would be 1. So that means now the limits of integration becomes 0 and 1. And tan n plus 2 in the power will become u n plus 2 plus tan n will become u power n. And now we need to change dx. To change dx, we're going to use u is equals to tan x first. Differentiate both sides with respect to x. So du by dx equals secant square x. All right, but we need this in terms of u. So secant square can be written as we know the identity 1 plus tan square x is equals to secant square x. So that means 1 plus tan is u, tan x is u. So this becomes 1 plus u square equals secant square x. So we write du over dx equals 1 plus u squared and du upon 1 plus u squared equals dx. So in place of this dx here, we will write du over 1 plus u squared. Let me use brackets here. So du over 1 plus u squared. Okay, now notice in the numerator, we can take u power n common and then we'll be left with u squared plus 1 in the numerator. Okay, how did we get that? There's un plus 2 plus u power n in the numerator. This can be split into un times u squared plus u power n. And now when you take u power n common, you're left with u squared plus 1. Okay, in the denominator, there was already a u squared plus 1. So when this cancels, we get u power n. Now this integrated becomes u n plus 1 over n plus 1. Okay, now n is 1 or n is 0. So when u is 1 or u is 0, so 1 over n plus 1 over n plus 1 minus 0. So we're just left with 1 over n plus 1. So we have done the first part. Part 2 says, hence, find the exact values of these integral. Okay, hence means we'll be using the results found in part 1. Okay, first of all, in part 2, part A, we have secant, and in part 1, we had tan. So first we're going to convert secant into tan using the identity 1 plus tan square x equals secant square x. Okay, so that means secant 4 power 4x would be 1 plus tan square x whole squared. Okay, so we get 0 pi by 4. Instead of secant 4x, I'm writing 1 plus tan square x whole squared and minus bracket 1 plus tan square x dx. Let's simplify this. We get a squared plus 2ab plus b squared minus 1 minus tan square x. So this and this cancels, this and this cancels. So we're left with 2 tan x dx. There seems to be a mistake. Yeah, big blunder. This was supposed to be tan 4. So that's tan power 4x. So that does not cancel. Okay, so now the ones do cancel, 1 and minus 1. So we have tan 4x and plus tan x plus, sorry, minus tan square x. I'm sorry, this was also tan square x. That was confusing me. So now we get tan 4x plus tan square x. Okay, now it makes a lot of sense. Okay, so I was getting this wrong. All right. So now, how do we use the result of part A to solve this? Also, the limits are the same, 0 to pi by 4, as in part A. So in part A, we had n here, and now we have 2 here. And here we had n plus 2, and here we have 4. So n is actually equals to 2. So the result was 1 over n plus 1. And now we'll write 2 plus 1. So the result of integration is 1 by 3. Part B. In part B, we have to integrate from 0 to pi by 4 tan power 9x. Okay, after tan power 9x, we should have tan power 7x if we want to use the result of part A. But here we have 5 10 power 7x. So what we'll do, we'll write it separately. We'll write 1 tan power 7x separately, and then 4 tan 7x separately. And then here we'll write 4 tan 5x separately and a single tan 5x separately. And in the end, we have tan cube x. Now we're going to keep using the rule or the result shown in part 1 in these pairs. So we'll use that here, and then we'll take 4 common and use that here, and then we'll use that here. So here n is 7. So we get, after integration, we get 1 over 7 plus 1. In the next one, we're going to take 4 common, and then n is 5. So 1 over 5 plus 1. And then 1 over n is 3 now, 3 plus 1. So we're getting 1 by 8 plus, that becomes 4 over 6, which is 2 over 3 plus 1 over 4. Add these all together. And we get 25 by 24, and that's going to be the final answer.